Hey everyone, hope you're having a good day so far. Today's lesson is going to be on trig identities, and your aim for today is how do we use trig identities to evaluate trig functions. Your homework is going to be in the OpenStax textbook, page 484, numbers 39 to 47 odd, and then page 485, numbers 67 to 68. All right, for the objectives for today, it's going to be state three main trig identities, and then we have use the trig identities to evaluate trig functions. All right, do now for today is kind of long, so I'm going to go to that slide for that. All right, here it is. So let cosine t equal x and sine t equal y, where x and y are the coordinates of a point xy on the unit circle. Remember that the equation for the unit circle is x squared plus y squared is 1. Part A. What trig identity can you come up with using the equations mentioned above? Okay, so using this equation and then these equations. Part B, we're going to divide both sides of the equation from part A by cosine squared t, given that cosine t is not equal to 0, because otherwise it would be undefined. And you're going to find that we're going to get an identity. Part C, we're going to do the same, but this time we're going to divide by sine squared t and find an identity. All right, so if you need to copy this down, please pause the video here. Otherwise, I'll move to the solution. All right, here we are. So here, right, so we know that cosine t is equal to x. We're going to let that, right? Let that equal x. And then sine t, we're going to let that equal y. So we're just going to plug it in, right? So cosine t is x. We're going to get cosine t squared for this part, and then plus sine squared t for that part, and that equals 1. Okay, so that's your answer for part A. Sine squared t plus cosine squared t equals 1. Okay, so this is our first trig identity. Part B, we're going to divide both sides by cosine squared t, and you'll see that. So let me do the work here. So let's see, sine squared t, divide that by cosine squared t, copy that, and then cosine squared t, divide that by cosine squared t, and then remember we do have to divide the other side also. But yeah, we're going to get, so sine squared t over cosine squared t. Now this can be seen as sine of t divided by cosine of t, and this entire thing is squared. Okay, so basically I'm just basically rewriting the exponent. Okay. And then over there, cosine squared t divided by cosine squared t is 1. And then on the other side, it's 1 over cosine t. That entire thing is squared. Okay. All right. So if you remember from last year, sine t over cosine t is equal to tangent. So this is going to become tangent squared t. And then plus 1 is still plus 1. And then on the other side of the equation, we get 1 over cosine. And if you remember that from our last lesson, right, 1 over cosine is secant, right? So secant squared t is going to be on the right side. So overall, it's going to be tan squared t plus 1 equals secant squared t. Okay, that's our second trig identity. Next, we have this first equation divided by sine squared t. So let me do the math again. This divided by that, and plus cosine squared t divided by sine squared t, and then that equals 1 divided by sine squared t. All right, so I won't go through the math like I did in part B, but yeah, sine squared t divided by sine squared t is 1. And then, yeah, we would do the same thing as we did in part B, right? Just rewrite this as cosine t divided by sine t squared, and that'll be cotangent, right? So cosine over sine is cotangent, right? Because sine over cosine is tangent. So the reciprocal of that will be cotangent, right? So we're going to get 1 plus cotangent squared t on the left-hand side. And then on the right-hand side, we have 1 over sine t squared, right? If we rewrite it like we did in part B. But 1 over sine t, that's equal to cosecant t. So on the right-hand side, we're going to get cosecant squared t. And this will be your final identity. 1 plus cotangent squared t equals cosecant squared t. All right, for the remainder of the lesson, before I get into that, if you need to copy any of this, so if you need these 3 solutions, please pause the video here. Otherwise, I'll give you the overview of the lesson. Okay, so the rest of the lesson is we're going to go into the reciprocal identities. So just a recap of kind of like what we did last time, right? But this time we will also define cotangent in 2 ways. Next, we have the Pythagorean identities, which we have from the do now, and then just a few examples. And then after the Pythagorean identities and the reciprocal identities, we're going to go through the even and odd properties of our trig functions, and then some more examples and classwork. Okay, so with that, let me get to the slide. All right, so here are the reciprocal identities. So please copy this down. Cosecant t is equal to 1 over sine t. Secant t is 1 over cosine t. Cotangent is the reciprocal of tangent. Tan t can also be seen as sine over cosine, and then cotangent is cosine over sine. Okay. And then you also have your Pythagorean identities. So sine squared t plus cosine squared t is 1. 1 plus tan squared t is secant squared t. And then lastly, 1 plus cotangent squared t equals cosecant squared t. And then after you copy this down, I'll go back to the lesson to give you some mnemonics. Warning, they are kind of corny, but they help, students remember. So I'll provide them for you. Okay, I'm gonna go back. If you need this, pause it, but yeah, I'm gonna go back to the lesson. So here we are. Here are some mnemonics you can use. So, for tangent, so I actually just noticed this as, I am a big fan of basketball, and Steph Curry is one of my favorite players, and his initials are SC, right? So SC, right, sine over cosine, and his skin is like tannish, right? Tannish colored. Okay, but yeah, so if it helps you remember, please remember it. If not, then whatever. But yeah, tan t equals sine t over cosine t. That's how I remember that. And then for the Pythagorean identities, this one, so 1 plus tan squared t equals secant squared t, you might remember this as I tan by the c. So the 1 is I, and then tan is tan, and then secant is represented by the c. Okay, so I tan by the c. So yeah, feel free to use these if they help you. If not, you can forget them. Okay. Lastly, we have 1 plus cotangent squared t equals cosecant squared t. All right, sorry for that bell. But yeah, this is that last Pythagorean identity, and you can remember this as I buy my coats from Costco. Okay, so 1 is I, cotangent is coat, right, and then Costco, CSC on the other side. All right. If you like him, great. If not, forget him. Okay. So hopefully you got a laugh from this. I know they're corny, but yeah, hopefully it helps you remember these. All right, next we're gonna go through these examples. So here we have sine t equals 3/5, and t is in quadrant 2. What is cosine t? So we have sine squared t plus cosine squared t is 1. Where all we're gonna do is just plug it in. All right, so we have 9 over 25 plus cosine squared t is 1. Subtracting 9 over 25 from both sides, we get cosine squared t is 16 over 25, right? Because 1, you can see that it's 25 over 25. So 25 minus 9 is 16. So we get that. And then from there, we're going to take the square root of both sides. We're going to get cosine t is plus or minus 4/5. But since t is in quadrant 2, right, we're given that. We have to think, is cosine negative or positive in quadrant 2? So quadrant 2 is going to be a negative x coordinate. Okay, so it's going to be cosine t is negative 4/5. All right, so that's how we choose which one, right, whether it's positive or negative. We know that's negative in this case. Okay, so that's your answer for the first example. Next, we have write tan t in terms of cosine t, where t is in quadrant 1. Okay, so we know that everything is positive in quadrant 1, just like this class, right, all positive. So let's find cosine t. or sorry, tan t in terms of cosine t. Tan t is sine t over cosine t, right? We know that from the reciprocal identities. And so sine t, here I wrote, so I did the math down here. So sine squared t plus cosine squared t is 1. And we can simplify that further by writing this as sine squared t equals 1 minus cosine squared t, right? So I just subtracted cosine squared t on both sides. And then taking the square root, we get sine t equals plus or minus the square root of 1 minus cosine squared t, which is what we get over here in the numerator, okay? So actually, well, if that helps you, let me write it out here. So sine of t equals this thing in the numerator. Okay, right, we just took the square root of both sides. Okay, let me change the formatting. Okay, start like that. Okay, yeah, that's what you get. So plus or minus square root of 1 minus cosine squared t. All right, so that's what we get in the numerator, right? So we're just rewriting sine in terms of cosine, right? And that's how we do it. Cosine is still cosine in the denominator. And then for this step, we know that t is in quadrant 1, so it has to be positive, right? So it can't be negative because we know that tan and all other trig functions are positive in quadrant 1. So we'll have that. And then, okay, I don't know why this is on the outside. Sorry about that. Write that there. All right, yeah, just some formatting things. I have to. All right, that's better. Okay, so square root of 1 minus cosine squared t over cosine t. And that'll be your final answer for this example. All right. Next, we have the even and odd properties. And for that, I'm going to go to the slide. This. So we already saw this. Did those examples. All right, even and odd properties. Okay, even and odd properties. If you remember from one of our previous lessons in our first unit on functions, right, we already did talk about this. So even functions are symmetric about the y-axis. And algebraically, that means that f of negative x equals the original function. Odd functions are symmetric about the origin. And algebraically, that means f of negative x is equal to the negation of f of x. So in other words, f of negative x is equal to negative f of x. Okay, just a reminder, but let me read this slide for you. Sine, cosecant, tangent, and cotangent are odd functions. Cosine and secant are even functions. Okay, algebraically, that would mean this. Sine of negative t equals negative sine t. Cosecant negative t equals negative cosecant t. And then the same thing for tan and cotangent. All right, sorry for that second bell. But yeah, these are odd. So yeah, these are going to be symmetric about the origin, meaning if you reflect over the x and the y-axis, then you get, the other half of the graph. If you don't remember that, feel free to go back and watch my even and odd functions lesson. Anyhow, cosine and secant are even functions. Okay, so in other words, cosine of negative t equals the original cosine t, and secant negative t equals secant t. Okay, so these are even. The other four are odd. And then after that, we'll do this example. Okay, but if you need to copy this down, please pause the video here. Otherwise, I'll go back to the lesson. Okay, so just one more mnemonic, one more corny mnemonic for you to help you remember. So if you look at, so cosine and secant are even, right? So I just remember these, and then I just remember that the other four are odd. And the way I remember that cosine and secant are even is the following. So take the first letter of cosine, which is C, right? So cosine C, and then the last three letters of secant, which is ant, right? So if you combine them, you get can't, right? And then as you guys say nowadays, right? I can't even. Get it? Right? So C, and then ant, can't, secant, even. Okay? I can't even. Take cosine and secant are even functions. If that helps you, remember it. If not, forget about that corny joke. I apologize if you are cringing right now, but on that note, we're going to get to the example. So let's finish this lesson. Okay, so use the even and odd properties of the trig functions to determine each value. So we know that sine is an odd function, so sine of negative x, or sine of negative of any value is going to be negative sine of that value, and then cosine is even, so yeah. So sine of negative pi over 6 is going to equal negative sine of pi over 6, right? We just use that property. And then we know that sine of pi over 6, so pi over 6 is 30 degrees, so sine of 30 is 1/2. Okay, so this will be negative 1/2 as your final answer. All right, and that's again because we know that sine is odd. All right, part B. Cosine negative pi over 4, we know that's equal to cosine pi over 4 since cosine is even. And cosine pi over 4 is root 2 over 2, so that'll be our final answer there. All right, if you need any of this, please pause the video here. Otherwise, we'll be moving on to our classwork. All right. All right, quick water break for me. All right, so but here are your questions. Cosine t is negative 5 over 13. T is in quadrant 2. Find all trig function values. And this will be similar to a few of the homework questions that you're going to see tonight. So to find sine, we're going to use that first Pythagorean identity. Sine squared t plus cosine squared t is 1. And we're going to plug that in, right? So cosine is negative 5 over 13. We square that, we get 25 over 169. And then we subtract this from both sides. We get sine squared t is 144 over 169. Take the square root, you get sine t is plus or minus 12 over 13. Okay, now we know that t is in quadrant 2, and we know that sine is positive in quadrant 2, right? So if you remember the mnemonic, all students take calculus, sine is positive there. So sine t is 12 over 13, okay, positive. Tangent, I'm gonna take sine, divide that by the cosine value, so it's 12 over 13 divided by negative 5 over 13. So that's 12 over 13 times the reciprocal, negative 13 over 5. 13 divides out, you get negative 12 over 5 for tangent. Okay. All right, next we have cosecant, which is 1 over sine, and just take the reciprocal. That's easy, 13 over 12. Next we have secant, which is the reciprocal of cosine. We get negative 13 over 5, right? Just taking the reciprocal of this, we get that. And then cotangent, take the reciprocal of this. We get negative 5 over 12. Okay, so easy enough. There's your first set of answers. All right, question 2. Cosine t is 3/5. T is in quadrant 4. Find all trig function values, okay? We know that quadrant 4, so all students take calculus. Cosine and secant are positive here. Everything else is negative. All right, so to find sine, we're going to use that same Pythagorean identity. Sine squared t plus cosine squared t. So cosine squared t is 9 over 25, and that equals 1. And then sine squared t, after subtracting this on both sides, we get 16 over 25. Take the square root, you get plus or minus 4/5. And since, I don't know why this is quadrant 2 here, so this should be quadrant 4, sorry. So we know that this is in quadrant 4, so sine is negative either way. So sine of t will be negative 4/5. Okay, well, quadrant 2, it's positive, but yeah, so it's quadrant 4, so it's negative. Okay, sorry about that typo. So it's, yeah, quadrant 4, negative 4/5. All right, tangent is next. Sine over cosine, we get negative 4/5 divided by 3/5. So negative 4/5 times the reciprocal, 5 over 3. 5 divides out, you get negative 4/3. All right, next we have cosecant, which is 1 over sine. So just take the reciprocal. We get negative 5 over 4. Secant is 1 over cosine. We get 5 over 3. Then cotangent is the reciprocal of this. We get negative 3/4. Okay. All right, those are your answers for question number 2. All right, next we have question 3. So here it's write secant t in terms of tan t if t is in quadrant 2. Okay, so here we're going to use that third, or I think it's the second one, but one of the Pythagorean identities. It was 1 plus tan squared t equals secant squared t. So we're going to isolate secant, right? So we're going to write secant. So we're going to isolate this first term. Okay, so secant, take the square root of both sides. We get secant t equals plus or minus the square root of this, right? 1 plus tan squared t. We get that. But we know that t is in quadrant 2, right? And secant, we know that's negative in quadrant 2, right? Because only sine and cosecant are positive in quadrant 2. So we're going to choose the negative option. Okay, so negative square root of 1 plus tan squared t, since t is in quadrant 2. All right, and this is your final answer right here. Right there. Okay. So that's your final answer. Okay. Outside of that, that is all I want to say for today. If you need any of this, pause the video here. And yeah, I think, oh yeah, so this is the worksheet that you'll see. You know, we just completed the solution for these. But yeah, just remember to submit your homework by tomorrow night, and I'll see you all in the Zoom session. Take care.